Hey everybody, welcome back to another layer by layer tutorial. On today's tutorial, we're going to continue the project we worked on yesterday, which is a multi-purpose enclosure for the feather line of boards. So if you haven't seen watch back, I'll have a link down below for yesterday's stream where we started an enclosure for the feather line of boards. This was inspired by Bill Binko of AT Makers, and the main goal of this project is just kind of make a enclosure that will work with all of the feather boards and a battery and a couple of the components. So the goal is to have different tops that will be used for different situations. So we'll kind of make one for the feather wing so that you can the OLED feather wing so you can kind of see that through the top, or we'll have kind of mounting holes for different type of components like a buzzer. So we kind of had a open discussion yesterday where we were kind of going back and forth between the batteries. So we ended up going with this battery as opposed to this one. So that's what we're going to be using. And in today's tutorial, I just kind of want to walk through kind of the updates that I did off camera, and most likely design this component, the feather wing OLED in Fusion, so that we can create a proper topper for it, so that we can have the right clearance and openings for the screen and maybe the buttons as well. So that's what we're going to try to do today. But this is kind of the prototype that I came up with. It is a little bit bigger than the feather so that we can house the battery. The goal that we came up with is to kind of have a separate component, or like a compartment for the battery, so it's going to be like a separate thing, so that if folks don't want to use a battery and have it plugged into the wall, or an external power source via the USB, you don't have to kind of print that part out. So that's why the enclosure is bigger than the feather. It is kind of designed around the 2000 milliamp hour battery. You could use the 1200 milliamp battery as well, because it has the same X and Y. It's just a little bit thicker on the Z. So and the goal wasn't to really put this on top, because then you wouldn't have access to put a feather wing on there. But this is kind of what I came up with. So, and the print just finished, so I'll take a look at that in a second.
Grab it.
Yeah. So this is kind of print number 2. Just kind of trying to dial in the settings. I got quite a bit of kind of blobs and zits. Oh no, you've completely destroyed the bed.
Happens.
Well, I guess so. I did have some. Is there a little bit of warping? No, I think it's flat. So one of the cool ways to kind of alleviate warping is to just have a big brim, and that's what I did here. So I printed out this big brim here. It's about 6 perimeters wide. Let me see if I can get focusing better. I think that'll do. So it's a lot more flat. As you can see here, the first prototype did warp a little bit, and there's still some zits and stuff. We can take a look at the slice settings, but I'm not too sure why that's happening. I did take a look at Simplify 3D's troubleshooting guide, and kind of sources point to having maybe the retraction needs a bit of a restart distance, or perhaps it needs wipe coasting turned on. So we'll kind of work through that, but yeah, it's a little excessive here on that. Not too sure why. But I got the tolerances correct for the nylon screws so that they fit in here. They don't really, since they're nylon, they can't really create threads, so I had to kind of open them up a little bit more. And another thing is that because of the kind of shape of the head of the screw, they kind of protrude out, which I think is okay. It's not too much of a problem. I tend to use machine screws that are made out of zinc or metal or whatever, and they have kind of like a tapered edge, so that they're a chamfered bottom. These are just kind of flat, so they kind of protrude out, which I don't think is too bad of an issue. Maybe they can be used as like a little feet or something. Not too bad, but it fits well. The goal was to kind of have access to the USB port, so you always want to have a little bit of clearance for the USB. Where's the USB cable? Where did it go?
That's down there by your feet.
Oh, that's where it went. So if you'll notice that there's like a bit of an indentation here on the port opening, so it's not just a hole, it's actually a little bit of an offset, so that when you plug it in, the the connector kind of has a bit of a open area so that I can get plugged all the way into it. The enclosure is 3 perimeters thick, so it's got a good strength to it. If it was just 2 perimeters thick, it probably wouldn't be as strong. So with that, I can do this kind of indentation here for the USB connector. But that seems to work out really well. I noticed that although it looks like there's a lot of gap here, like clearance, I find it pretty difficult to actually plug this in. So this is the battery, and this is the JST, the male connector, and this is the female connector. There's enough room to get it in there, but you kind of have to finesse it. I would probably recommend like plugging in the battery first and then securing it to the enclosure, because I kind of can't. Maybe I can work it in there. I know there's enough room. You can kind of see that there's enough room. I just kind of have to do this little number where it's right angled and then kind of futz with it, but I don't feel like futzing with it right now. Oh wait, there we go. So there you go. So most likely what we'll have to do is put a hole somewhere here so that this can actually get threaded through the bottom, because we're going to have that external component here. So that's what we'll end up doing. But hey, there's enough room in there. And I ended up making it centered so that there's equal distance between here and here, and then this is just extra distance so that it kind of can encapsulate the battery here. There's also a slit on the back here so that we can have wires. Let's say we want to have wires kind of plugged in here and then kind of coming out this way. I made sure that it's a slit so that you don't have to thread individual wires through there, so that's why there's a slit. So that's kind of it right now. Here's the... Yeah, there's still some stuff to do there. Another thing is I don't have holes on these back standoffs, mainly because the feather boards actually all are slightly different. They do have the same mounting holes for the fronts, but the back is where they differ, so that's why I opted out of using actual holes in the standoffs, because it would kind of be difficult. We would end up... The goal here is to have one enclosure for all of them. So one thing I did note is that it is secured, but if you have something like this plugged in, you have to kind of hold this down, because you get this sort of this action here. And actually, when I pulled it off before the show started, I bent these guys, the little pins, so I had to kind of flatten them out using a flat pair of pliers, which is okay, but kind of be careful. So testing that out is always important to make sure that you can get things in and out. But that's how it would go. I'll probably have... Is it backwards? No, it's the right way. So hopefully that works out okay. It is a little bit thick. It is a little bit, yeah, thick. But I think it's okay. So, all right, let's take a look at the CAD stuff now. So in Fusion 360, here's kind of what I have set up. I did come up with these. So here's the topper, right? Here's kind of like the generic top. Let's get that. There's a generic top right there, and I made it see-through so you guys can see. It does have these little nubs, so if I hide the case, you can see these little nubs here. I haven't printed this out yet, so I'm going to get that started soon. But the idea here is that these nubs, or these indentations, will allow the nubs from the enclosure to kind of clamp together. I also added some chamfers on the sides here on both of the parts so that your fingers can actually get into it. So you can see here on these edges there's chamfers. That way you have more of an area to open it. And I think what's cool is that you can kind of get your finger in here and just kind of lift up to pop this out. Since I probably don't need these little nubs on all 4 corners, or all 4 sides rather. So I think that'll work okay. But I might need to kind of get rid of this one, because...
Make sure that you're on the CAD screen.
Oh boy, I keep messing up. Thanks guys. So where was I? Yeah, I'm just kind of showing off the design where it is right now. So some of the things I did was I did make the top, and you can see the top has those nubs like I was saying. So let's just kind of get a look at that. By making it transparent, you can kind of see that there is a little bit of clearance there, which is always a good thing to have. And there is that chamfer along the edge of the 2 objects so that your finger can get in there. And then if you look on the back here, there's an opening here in the slit so that you can kind of get your finger in there and pop the thing off. So no need for a nub there. And I think I'm going to get rid of the nub on this side, because if you look at the feather component with headers, it's kind of intersecting with that indentation part. So if I open that up, you can kind of see, yeah. So I'm going to probably get rid of this nub here and just leave the side ones. And that should be enough to hold it in place, hopefully. So hopefully we'll get that. I did bring in the kind of feather with headers. So before, when I was designing, I was just designing around this one, which is is it the blue fruit? Yeah, the BLE feather, which doesn't have those headers. So I kind of reworked this one to have those headers. Let's take a look at the sketch real quick in the main. So I tried to kind of have it centered, because I did have it wasn't really centered, at least on the y-axis. So I got that, and I added a couple of user parameters here. So I have the margin for the right and the sides. So this is the right over here, and it's basically being driven through this guy, which is the battery. So there are some projected edges here from the battery, so that if I ever need to adjust that, it'll kind of adapt with it. So if we take a look at the enclosure as a whole, let me get out of the sketch. If we take a look at the enclosure as a whole, we can still modify the width so that these nubs here will actually adapt with it. So if I change the side margins from 8 to 12, you can see the enclosure updated. Those nubs kind of moved along with it. So if we ever have a bigger battery or something, I can quickly push out an update. So this was what, 8? Put that back to 8, and that seems to work okay. So that'll hopefully work okay. The height is still adjustable. So if I update the height from 16 to 26, for example, that's a little excessive, but everything kind of updates with it. Again, those nubs get updated, and the topper gets updated with it as well, and so does the slit. So the slit is also driven with a collinear constraint, so that it is okay. So what was this, 16 or so? Yeah. So very important to kind of have that kind of apply these user parameters before designing it, so that you know what features need to kind of adapt with it. So hopefully that works out okay. But that's kind of it for the enclosure. I really want to get this topper kind of sorted out. So in order to do that, well, this topper will probably work. So let's get this in to Fusion 360 real quick, and I'll have it printing in the background. So I'll save it out. And then bring it into Fusion, or not Fusion, Simplify 3D. I'll probably have to flip it. Yeah, I'll flip it so that this side is on the bed.
That's Control L too.
You can use Control L, yep, like that. And then we'll do a quick look at the settings. So there's nothing really too fancy about it. I'm using the 0.4 nozzle with a 100% multiplier, or 1.0 multiplier if you're using Fusion Simplify. The extrusion width is set to auto, which is normally is set to 0.48, and the retraction is set to 1 millimeters for the distance. If you're using a Delta bot, it'd probably be something bigger, but I'm using the printer bot in the background. Yeah, it's like 4 to 6, something like that. And the retraction speed's set down lower to 20 millimeters a second. Those blob and zits that you see, usually they come when the extruder is kind of trying to loop around the perimeter, and to kind of relieve some of the pressure from the nozzle, you can kind of enable this, but I don't think I need it right now. But that might be one thing to consider. Nothing too crazy here, just using a 0.2 layer height and 2 shells for the outer perimeter. 100%. First layer height is 100, same thing with the width, and then the speed is half that speed. It's speaking of speed, I'm printing at kind of slow, not too slow, but okay, 50 millimeters a second on the default printing speed, and then 70 millimeters a second on the movement speed. And then the outline is set to 50, and the solid infill is set to 100. There really isn't much infill since all of these parts are just perimeters. What's that? What do you want to look at?
Just wanted to see it.
Oh, sure, yeah. So thin wall behavior is set to use thin perimeters because I don't want any of the excessive infill gap. I really don't have much there. As far as the ooze control behavior, it's kind of the same stuff. Only wipe the extruder for the outermost perimeters. Maybe I need to turn that off. I'm not sure. And only retract when crossing open spaces, force retraction between layers. So if anybody knows if one of these checkboxes will kind of alleviate those zits, let me know. Pages in the chat room, he'll see it if you say anything. But other than that, I think it's okay to print this way with these settings. So let's take a look at it. Again, having that big brim with 6 millimeters will keep it down, or 6 perimeters will keep it down.
Let me grab you some more tape.
Yeah, I forgot. Before I can print this, I need more tape. It's pretty solid as far as the top and bottom layers. I think I set it to 6. So there's a few of them. There's a tiny bit of chamfer there. So it doesn't really translate too well. I mean, the more layer height you have, the more detail you will have there, but I don't think I need that much detail. So hopefully it comes out okay. So we can watch Pedro fix that. So while Pedro's fixing that, I am going to get started on modeling the featherwing component. So
there's some
what's that?
some suggestions that have the JC extension.
JC.
Or the battery connect with the JC extension. So maybe making like a panel mount.
I don't
mount like a panel mount.
Right.
Connect to it.
Well, I think the batteries have a pretty decently sized cable, so I don't think you need an extension cable. What other oh, maybe to alleviate that problem of actually connecting the battery to the feather.
Yeah.
I don't think it's that much of an issue. I mean, you saw me put it together. It's just the angle that my hand is at in order to get it in the shot was a little bit hard, so I think that was my issue, but there's enough clearance for the thing to connect to. But I can see where a JSC extender will kind of have access, will give you more freedom to kind of plug it in, but I think that's okay. But it is an option. So the featherwing has its own guide like any Adafruit component, and in order to kind of model this, I'm going
raise the
bed.
raise the bed.
Oh, sure. Is that good?
Should be good.
Okay. I have the squeegee over there if you need it. There you go. Cool. All right, so what I did was I went ahead and downloaded the EagleCAD file. So you can grab most of the EagleCAD files for all of our components from the guide. So if you go to the download section, there is a download the PCB in EagleCAD. So what I'll do is I'm going to grab the tech drawings or the dimensions for the featherwing. It looks like they are kind of laid out here. Some of the things like the buttons aren't laid out, but at least I have like the mounting holes and things like that. So if you click on a picture, you can get a bigger size of it. So you can see here. But I'm just gonna use the dimension tools inside of EagleCAD to get a better idea of the size of the buttons and things and where they are relative to the board. So let's get printing that topper just to make sure that our tolerances and stuff work out. There we go. I'm using Octoprint. Is everything okay there? Yep. Takes a second to upload. Give me a chance to kind of look at the chat room.
Yanni saying that the JC
Yeah,
extension.
yeah, I talked about it. It would make it easier to connect to the battery. Yep, that is definitely an option. And it wouldn't make it doesn't need to do that. You don't need to kind of modify the CAD, right? As long as there's a hole on the bottom of the enclosure, you can do whatever you want with it. Looks like folks are asking if you can use Fusion 360 for free. Yeah. There's always some confusion with Fusion 360. It's like, oh, is it free? What's this 1-year license deal? The 1-year license is for hobby makers that make less than $100,000 a year, and you can renew it after the license expires. So once my license expires, I will just renew it. So I have a download link if you guys want. There's nothing special about it. Just like kind of tracks who's downloading it, which is kind of neat. I don't get really kickbacks or anything from it. It's just a special download link for me. All right, stuff is uploaded. I'm gonna go ahead and kick off the print. The Merlin firmware on the printer bot tends to give an 8-second lead once the extruder is nice and primed, and then it'll kick off the start G code, which kind of does a purge. Okay, Terry is asking how to attach the box to a surface, like the cover to the lid to the enclosure. There's these little nubs. I'm not sure if that's your question, but there's these little nubs that will connect to it, so they kind of snap into place. And the reason why they're triangles is so that they get fitted in. So if you look at these little triangles in the edge of the case, on the very top of the case, the case. They're these little nubs, little triangular nubs, and then those will get kind of pressed into this lip here that has an indentation for those nubs, and then there's a little bit of an extrusion on the inside of the case lip. So this lip basically acts as a little friction fit thing, so you can see it with the transparency here, how it kind of works. And there's a little bit of clearance along the edge of the lip, so that it allows enough clearance for it to actually snap into place. But I'll probably end up getting rid of this one here, this front nub, because I think just having 2 on the sides is okay, or 1 on each side is okay. So that's how that's going to work. Okay. Yeah, it's at 180 right now. It takes a little. It's not like a Type A machine. It'll heat up in like 10 seconds. So while that's heating up, once it kicks off, Pedro, can you kind of clean the purge for me? Mm-hmm. Cool, thanks. So I got Eagle open already. Don't hate me. Don't hate the messenger. Hate the company. Don't hate the company. Don't do that. That's bad. So what I'm going to do is just kind of get some dimensions cleaned up or in here. So let's see. I probably don't need the vias. And I think there's already a dimension layer. So which layer is this? What's V-score? Well, that's interesting. Holes is there. I think it's under measures. Nope. Document. Dimensions is on, but I don't see them.
So Michael is asking, how can we weatherproof the box?
How can you weatherproof the box?
Epoxy maybe, like the XTC 3D?
Yeah, but I would just probably make little Ninja Flex kind of plugs so that you can close all of the holes. If your enclosure doesn't have any holes, then I guess you're safe. As long as you have like a nice weather-tight thing. But I haven't really made anything weather-tight, but I think that would be one way to do, is to make these like rubber Ninja Flex covers that would kind of like fit into the little port openings. So let me take a quick look. How's the first layer?
Doing good.
Okay, cool. Alright, that should take 24 minutes or so. Hopefully less.
Russ is saying O-rings for, I'm guessing, the parts where the lid snaps onto the case.
Yeah. So that it kind of gives like a watertight seal
Mm-hmm.
to all the openings. Yeah. Yeah, that's a good idea. Okay.
Another thing you can do too is maybe spray, what is it, Never Wet onto the
onto the
boards.
onto the boards themselves. So this is this coating, this weatherproof coating for electronics. It's called Never Wet. I think Becky was testing it out and kind of showing like having an Arduino underwater working.
Mm-hmm.
And as long as you don't have the battery in the water, I think you're okay, right? But the Never Wet coating is like, I don't know too much about it. I haven't used it, but I guess look back if you're interested in that Never Wet coating, and just search for that in Google, and maybe our video, Becky's video, will show up.
Might be able to heat shrink the entire circuit as well. Like just stick a, because she did that as well too.
Uh-huh. Just put the whole board bare
inside of
and heat shrink it. But of course, you know, you might not have access to it after that. You'll have to cut it open or whatever. Let's just get a tauntaun, cut them open, throw the board in there, and you're good to go. So there's a dimension tool inside of EagleCAD, and I'm going to use that to give me these dimensions. So I need to make sure to do it on layer 20. So the board should be about the same as anything, so 50.8 millimeters on the X, and on the Y I believe it's, I forget what it is, and that's why I'm doing it this way. 22.86. Okay. The footprint for the buttons look like they're kind of not there, but I mean that it's Eagle. I mean, you're not, maybe I hid the layer. I want to get rid of this the silk screen layer. I think it's that one. I'm gonna get rid of all that. Maybe it's T place. T place. Yeah, that's the one. I kind of need those. Yeah. So I'm guessing these guys are the buttons, right? Yeah, these are definitely the buttons. There's what, 4 buttons? No, there's 3 buttons, A, B, and C, and then there's a reset button. So I plan to model definitely the PCB board, obviously, and then the OLED display itself, which is in a very kind of special spot, and then the 4 buttons. Let's see. I think the mounting holes are, what's the distance between them? 17.78 for those. And then the screen looks like it's in an odd place. No, that's just a little Adafruit logo. Okay, where's like the, there's the screen, right? That's gonna be tricky. And then these guys in the back. Where is it? Looks like it's the same. Yep. So the mounting holes from the left and the right looks like they're about the same. That's good. There's this kind of cutout, which is kind of interesting. So there's the cutout. And then I'm not sure how wide it is. So that's how wide it is, 5.08. So I think that's enough to kind of figure this out. So in Fusion, I'll get that new component here, another OLED wing. And one thing I didn't know is that the document, yeah, it's there, okay. So this is like the origin of the document, so it's sort of like 0, 0 from an X and Y standpoint. And everything kind of gets pushed out that way. So I'll kind of make it the same. Oops, wrong. Don't want to use the center rectangle. 22.86 by 50.80. Yep. 22.86, that's correct. So there's our main board. The mounting holes are, I believe, 2.54. And they're kind of using the same distance from the edge of the board. Then I'll do kind of like a little mirror action here. So I can do mirror and mirror this guy on that line, and then maybe run it again. Well, I need a center thing. Oops, use the line tool. I'm using the line tool for making these construction lines, and then using the X key to do that normal construction thing. So I'll do another mirror here. Mirror these two guys on that vertical line, like that. Hopefully that is correct. I think if I do a quick measurement, it should be 2.54. Yep, should be fine. So that's the main PCB. The thickness of the board is 1.6 millimeters. And then there's a little fillet on the edges here. Of 2.54 also. So there's our PCB. Actually, I forgot to do the cut, so let's go back in there and do that cut for the ribbon cable, I believe, the flex cable for the actual OLED. So it's somewhere over here. And I think it is, let's do collinear, so it's on the edge of the board. So it was 5.08, and then it is 10.16 wide. Okay, so I got those in there. Now I need to kind of figure out the distance from this guy. Dude, it's kind of tough. 5.08. Just off by 0.8. It looks kind of odd, doesn't it? Oh, that's the way it is. See, the cutout isn't actually because there's some resistors here, that's why. So it's not really centered. So let's okay that and jump into that extrusion and just get rid of that. It is pretty sharp. There aren't any fillets on that edge, so there we go. That's what we got so far. How's the chat doing?
Good. Just chatting with them. Let's see.
Harry's saying maybe I need to start printing lower speeds as well. Yeah, I think the default speed for like the PrinterBot Cura profile is like at 50, just to kind of. Yeah, I tried printing it at I think 60 millimeters a second or 70, and it came out really, really bad. Like, this thing came out awful. I just want to show you how awful it came out. Look at that. It came out so bad. I don't know why. I guess because it was too fast, so I slowed it down. Look at that. Like, what is the deal there, man? That's crazy.
Yeah, so on almost all the printers, we're usually at 50 to 60 millimeters a second, but on the Type A machines and the Flash Forge, we can go up to 90 millimeters a second.
Yeah, it really depends on your printer. Yeah. Yep. Cool.
And I think the TAS, the default is 120 millimeters a second. If I
The default
remember.
speed?
I think so. Or is it 100 millimeters
Yeah.
a second?
I don't know. Kirby could tell us.
I vaguely remember that. It was at 100 millimeters a second for their default speed.
Oh, that's a good point. Grog in the chat room is saying that he thinks that the firmware limits the max printing speed anyways. So even if you do tell your slicer, the firmware will be like, nope.
Also, things that slow it down are whatever speeds you have set in Simplify 3D for outer.
Yeah, your outer speed is always like, what, 50 or 80% of whatever the default is. Harry's saying he uses 80 on his MK2. I'm assuming that's the Prusa.
Yeah.
Prusa MK2. Okay. Alright, so how big is this LCD screen? Let's get that kicked off here. So this is the... I'm going to project that there. It's a little tricky. Yeah, I need a finer pitch grid. So that's a really fine pitch there. So I'll start from there. Zoop. I could try using the info inspect tool to see what the actual thing is. But it doesn't really give you a thing. See, it tells you the position relative to the origin, but that's not going to help me here. And the package is a set of the micro library, which I don't have access to, so I can't kind of go inside and edit the main library component from Eagle. It's just kind of baked in there. So this is kind of like a hacky way to do it, is to figure out, just use your dimension tool. So it's 29.97. And then we'll see what the width is. So it looks like 11.3. And then we'll see how far it is from the edge of the bottom. Looks like it's at a curve there. It's at an angle. It's kind of weird. There you go. It's better. 5.97. Well, that is tiny. Oh, no, no, no. Sorry, that was the wrong thing. Yep. Okay, and then we'll find out from this edge. Hopefully that's not too much of a hassle. Looks like it's going to be 13.46.
Does Wirecast enable on-screen keyboard presses?
I don't think it does. That would be cool, huh? So you can see what key commands I'm doing. Mm-hmm. Yeah. I know ScreenFlow does, but it's not the same software. It's a little bit different. I usually talk through it, but I'm kind of in the thick of it. So what I'm gonna do next is, sure, I get the X and the Y for the OLED screen, but I don't know what the thickness of the screen is, so I'm gonna have to use my calipers to do so. So here's an opportunity to do this. How do you find out, right? The bottom of the caliper, so these are my calipers, the bottom of the calipers has this little nub here, and you can kind of determine what the thickness of something is by kind of having this be on one thing and this be on the other. So let's see if I can get this in the right shot. First of all, make sure it's zeroed out correctly, because it's not. So I'll zero it out. Okay. It's probably like 1.6. 1.62.
Right, we're saying that maybe there's a plugin for enabling key presses.
I haven't looked into plugins for Wirecast. I don't know if they have an API or let folks do that. It's definitely worth looking into. Alright, so I got my OLED. The next thing. Yep.
Harry's asking about the AstroPi tutorial you did. He's noticed that you have the UI on the screen. I'm just wondering how you did that.
I'm using a plugin. Wait, oh, AstroPi. Yeah, that's just a browser. It's using Chromium, so what you can do is have this terminal mode inside of Chromium, which is the browser software for the Raspberry Pi. And I believe I have. It's not in the tutorial. I believe I put in the tutorial how to kind of set that up and configure it so that it opens up only in Chromium full screen, so none of the extra bits and bobs are all over the screen. So it's kind of a hack, but if you want it in that terminal mode, just search for Chromium Raspberry Pi terminal mode, and our tutorial should show up, or one of the tutorials on the learning system. You can export the library, says Natty, in EagleCAD. You can do that in EagleCAD, export the library. That way I wouldn't need to kind of make all these dimensions all over the place. I could just look at the library component and get the dimensions directly. I would love to do that. I don't know how to do that.
Yeah, he's saying that he's thinking Azure Media servers can stream and then hook from there to stream other services. So Tony D was actually looking at how to do this. I don't know if what the status of that is.
Yeah, I think we gave up on it.
I don't know if he actually had time to do it because of the
to multi-stream.
To multi-stream,
right?
Yeah. Tony D was looking into
right.
it.
Well, Wirecast does it. I don't have the bandwidth, but the idea was that one stream would go to an Amazon server, the AWS servers, and then there would be like a Python script that shoots that stream out so that your personal internet connection here wouldn't be reliant on multi-streaming. That was the idea.
I'll let Tony D know about the seeing if he knows knows about setting it up with the Azure server.
Azure. So what we're gonna do next is kind of, are they center? Yeah, they're center rectangles, so you can kind of do. I think that's what it is. I'm just using my calipers to figure out the dimensions of these buttons. So I'm gonna guess that's what it is. And then I can just use the inspect tool to figure out where it is. Those are inches. Let's go to millimeters. And then this is the Y. So that's our first button. Here's our second button. You have to keep remembering to like tab twice in order to lock that position in. So I'm just kind of getting these in the right spot using the dimension tool.
The screen.
Oh boy. It's difficult to I kind of want to get this done a little bit quicker than I'd like, so I'm not explaining too much. So all I'm doing is just getting these three buttons in the right spots. So that's all I'm doing, right? So that's all. I could probably use like a pattern thing, but I don't know what the distance between them is. I could figure that out, but maybe it's okay. I think this way is more. Did I get that right? There we go. Okay. How thick are the buttons? I think they are. Let me see here. Oh, it's so difficult to get this because of the way the placement of these buttons are. It's really hard to get like a flat surface on the PCB. So I might not have it exactly exact. So from what I see though, it's probably like 1.3. And then I need these little rounded buttons here. So it's kind of like I don't know what the radius is of them. Is that 1.7? Yeah. Oh, come on. There's no blobs on this one. Alright, so let's take a look at the part here. Can you all see that? Yeah. Nice and flat. Definitely the brim. I usually don't use a thick brim like this. But hey, it's working out okay here. You can just kind of break them with your hand. Or cut them, whatever. It's a little bit, you know. So it's supposed to be like this. Ooh, how is it? Tight fit. I can't seem to. I might need a bigger offset. The offset right now is 0.2 of a millimeter, so I might bring that up. But it could be... Oh, wait, this is the wrong enclosure. It's this one. This is the right enclosure. Because I cut it out because it was kind of failing, so... Let's see here. Phew. I feel like if I press it in, I'll never get it out again. If that was okay. Yeah, it's not working. So this is where a user parameter would come in handy so that I could kind of change the offset. But I don't think I designed it that way, so I'll have to kind of manually insert that offset. Yeah, the smaller your enclosure, the more, I think, clearance you need. You definitely don't need that nub here, so I'm going to get rid of that. Because if I didn't have to worry about it, then... Yeah, there's just too many points of friction in order to get these two pieces to sandwich together. So, that's what I'll do. Yep. Over-engineered, huh? Yeah, I don't need that right here. Yeah, so I'm gonna get rid of that right there.
Kirby's saying that we should get a deburring tool to clean up the brim.
With the burring tool, like a Dremel?
It looks like a... Is this a heated element?
Oh, that's cool. So it's like a little metallic sort of... This is a deburring tool. HDX deburring tool from Home Depot.
So usually I'm able to get the
No,
brims off.
I could do it with an X-Acto knife, but
Yeah.
maybe...
But it'd be nice to have a tool to...
Yeah. So it melts the plastic?
Just like spin to get it off?
Yeah, it's meant for metal and plastic.
Oh.
It's like the plumbing tool. That's pretty neat. I haven't really heard about it. I'll check it out. Here you go. Thank you. Thank you for that comment.
Also,
What you got?
we have a new version of
This just in, breaking news.
breaking news.
The
Bluefruit.
Adafruit Bluefruit LE Connect app for iOS has been updated. What's the new update? Check the
It
notes.
fixes wrong data on the control module.
Okay.
Check it out.
Cool. Is that K-Town or
K-Town
K-Town.
or
is it Colin?
either Colin, K-Town, or
Antonio? No.
Antonio
Attach.
or Attach.
Yeah, I think Antonio does
One of
the
those.
Android app. Have to make sure to remember to go back here. All right.
So it's not heated, just a sharp edge.
Oh. Gotcha.
And it chamfers it slightly.
Yeah, Mitchell is saying, isn't it shrinkage? Maybe it's shrinkage, and that's why it's important to have that extra clearance to allow for those tolerances to be a little bit loose and not so tight, because you do get a little bit of shrinkage.
So the shrinkage, I usually see it at either 0.4 or 0.6.
You do?
Yeah.
Well, I guess I didn't have enough because I have it at 0.2. So if we go back to the feather box, I have a analysis thing. So I kind of step through it. You can see it's not a lot at all. Yeah, so the first thing I want to do though is get rid of that, this guy here, this nub. I really don't need it right here on the front. So what I did is that you can, Pedro showed me this, I didn't know you can do this, is that you can create, you see this right here? This is a group. So if I expand that, you can see all the things that are in that group, and you can name the group. So I named it top. So all the stuff that have to do with the top are in that group. So it's one kind of way to clean up and manage your timeline. So if you don't know how to do it, you just kind of select a multiple of things, right click on it, and say create group.
But then you're not able to ungroup it, or did they fix that? Or was it that you couldn't add
remove, expand group. Ooh.
And then I wanted to add things to a group, just drag and drop it in there. I don't think it allows you to do that. So I have like groups, like 2 groups that should have been 1 group.
Yeah. So I'm going to grab this whole chunk here and just delete it. And then this one as well. I don't need that sketch. And so the top is okay. The top has been cleaned up as far as the nub or the indentation goes, but the case still has that nub. So if you click on a surface, Fusion does a good job of figuring out where that is in the timeline. So I'm guessing it's these guys here. And of course you get a deletion warning like, hey, some features are referencing other features. But from the looks of it, it looks okay. There's no yellow warnings or red warnings, so that's okay. So let's bring back the case, and yep. Okay. Cool. Now to create that offset, I believe I have to go in here. No. Where does it start? Here? Let's just open up our sketches. Here it is, top. Yo, there we go. So you can see here there's a little bit, here's how I built it, right? Just projected the top of the edge of the enclosure, and I did that so that if I ever update the height of the enclosure, this guy will go with it, because I am referencing this surface here. So that's why I projected it and created a new surface here. So top generic is being derived from just this top solid here. So let's kind of make this thicker. So I'll put 0.4, and then this one will be 0.4. So now I have that little bit of clearance. So hopefully if I hit stop sketch, things will just update. Hopefully. Yep, not too bad. So now if we do an inspection analysis here, we can see through it, kind of cut through there, and you see that there's now a bigger gap. If we look underneath it, we can see and do like a quick measurement. So I'll hold down the shift key, click on that edge, and then click on the surface, and then yep, the minimum distance here on the far lower right hand says 0.4, so we're good. So hopefully that is the proper clearance now. And if you're curious, the thickness of the kind of lip on the top here is just 1 millimeter thick. We could make it thicker, but I think two perimeters is okay. So you can see that here. Minimum distance is 1 millimeter. So let's try that. Let's get this printed next. Let me export this as a STL. That wasn't too bad. I thought it'd be a little bit worse. Not bad. Just giving a little note there when I do my saves over here. How's the thing? Is it? Yep, we're good. Command L. Oops. You can see here it's just 2 perimeters thick, and I believe 2 millimeters tall. Let's just overwrite it. Okay.
So you are way past not way past, but it's like an hour and 5 minutes so far.
Oh, cool. Well, this is probably as far as I'm gonna get. I mean, we could keep going, I guess. I did want to finish up the featherwing, the OLED featherwing. So I'm kind of in the midst of getting these 3 buttons modeled. So. Oh man, it still doesn't want to. Wait, there it goes. Whee!
No, these aren't rafts. We use brims most of the times.
Yeah, no rafts. It's just a brim. Raft would go on the bottom of it. Oops. On the bottom of the part. They're so small, these little buttons. So I got those. I guess the only thing I'm missing is the reset button. They're all the same button component, so.
Did you start a print on the Sigma?
No. I'm still uploading to Octoprint. Yeah, right, just keep going. Okay. I mean, this is what I do all day, so. It probably makes sense from a live stream standpoint, but I don't know how this will work for the folks watching, going, hey, I came here for a tutorial and I got a long live stream. I don't know.
Well, I gotta post a tweet, so I'll be back.
Alright, later. Thomas has 2 MakerBots and it seems to be an awful big waste of plastic. Which MakerBot? 5th gen or the... Oh, I see what you're saying. You're using a raft on the MakerBots. If you have really good leveling, you don't need a raft. It is a big waste of plastic. That's why I don't do rafts. I do, however, would use rafts for things that don't have a flat bottom. Alright, we're uploaded. Yay. Oh. Here we go. Alright, that's going to cook up, and then I'll start printing. I guess the last thing I'm going to do is just make that button. Modeling the pins, I don't know if that's necessary. I probably should make these bottom things. So I'm just debating in my head whether or not I want to make these guys here. The pins. I probably want this plastic piece modeled and correctly positioned so that you have a reference of when I put the 2 components together in Fusion, I know the correct distance from the bottom of this PCB to the top of the female headers. This way. So I'll probably model those in there. Yeah. I think I've done that once or twice before. But other than that, that's all I'm going to make. I got these 3 buttons, the display, the PCB, these little cutout. I'll get that reset button. And then I'm not sure if the cover should have like 3D printed buttons. It probably would be good because they're a little bit difficult to actuate. But I'm not sure. So just naming those. And then the restart button somewhere up here. It's definitely the same size as the other ones. So I just need to get some sort of dimension set. Maybe here's better. Let's find out what they really are. Oh, right. I can't really do it that way. I have to do it from here to this edge. Just kind of rounding them off for now. Okay, so I need to clean up this purge real quick, because otherwise it'll kind of get stuck to the part. I bet that kind of looks a little counterintuitive to kind of go and make sure your purge doesn't get attached to the part, but there are some tricks you can do in the Start G code where you can kind of get the printer to wipe its nozzle. I don't have that set up here. I just have it set up so that the extruder goes all the way up, like 20 millimeters or so, and then it extrudes out 20 millimeters or less. That way it's got the it's got the nozzle nice and primed. But, you know, if you're doing a brim, maybe you don't need that. I just haven't updated it. Mitchell's asking if we recycle failed prints to filament. He saw a video where they recycled the rafts into filament. Yeah, we experimented with the Filabot extruder, which is like a kind of a DIY filament extruder machine. I think to have a consistent diameter was a bit of an issue in having contaminants in your material. So if you're doing that on a personal level, I believe it's a little bit harder to do to get like a proper system going, because there's a lot of kind of processes involved to get a really good filament. And I think the kind of rule of thumb that I've heard is that you kind of need 30% recycled material and then 70% of quote-unquote virgin material. So I'm not too sure. There is a company that does sell recycled filament, or filament that is made from recycled stuff. I believe it's called oh boy, I forgot the name. If anybody knows what I'm talking about, let Mitchell know in the chat room. I think it's like, I want to say it's called recycled filament, but that would be too obvious, right? Yeah. Alright. So the print looks okay. And I'll get that last button in there. Do you remember that company that manufactures filament from recycled material? They did like a Kickstarter or something, and they used one of our designs as a reward or something, I want to say. I just don't remember the name. They're on Twitter as well. What's that?
I saw Adafruit went live.
What? Uh-oh. I need to end the stream?
Maybe.
Oh, crap. That's going to conflict. Are you sure?
I would probably do it since it's International Women's Day.
Okay, I gotta go, guys. There's another stream here, so thank you guys so much for watching, and let me know what you guys think of the thing. Like, comment, subscribe. I gotta go. Bye, everybody. Thank you.